All right, 4.1 is our, chapter 4 anyway, is our discussion of how things are divisible. And in particular, 4.1 is specifically about divisibility rules. And so some of these you know and you've seen them before. Others of them you might be like, oh man, it would have been nice if I'd known that earlier than now. So we're going to get started with some basic rules about, first of all, what the idea of something meaning divides means. So if we've got A and B and they're whole numbers, we say that B divides A if there is a unique whole number, Q, such that A equals B times Q. So just to give you a real quick example right here, 4 divides 20 because we can actually take, in this notation right here that this is using, we can actually take 4, or we can take 20, excuse me, and write it as 4 times some value, in this case 5. So that's why we would say that 4 divides 20, is because it actually goes in evenly. We talk about it not having a remainder sometime, but it's all about this idea of being able to be multiplied by another quantity and get you back to the original report. The notation here is something that might take a little bit getting used to. This is not a fraction, right? This actually says B divides 20. We read it just like that. B divides 20. So B divides A. In this case, 4 divides 20. So we would actually write this as 4 bar 20 if we were using that notation on that example. 4 divides 20. That's how it's written. So if you want to think about it, the fraction that corresponds to it would be taking this and turning it like this. I'm going to do that again with my hands. You guys see it. Taking that 4 divides 20 and writing it as a fraction like this. Okay, so this is not 4 division bar 20. Is everybody clear on that? That's a really odd sort of a notation because of what we're used to seeing with a division bar. The other word that we have here is the words factor and divisor, and then multiple as well. So we would actually say that since 4 divides 24 is a factor of 20, we would say 4 is a divisor of 20, or we would say that 20 is a multiple of 4. Those are all language that are related to one another, but they're easy to sort of switch back and forth if you're not being careful. All right, theorem 4.1 says that if you have any whole numbers, A and D, where D is a divisor of A, and N is any other whole number, then D is a divisor of NA. Now, you guys actually know this, and let me give you an example. We'll just use a real easy, even, odd kind of an example. So if 2 is a divisor of something, so tell me something that 2 divides. 6. Actually, that's what I was thinking. 2 divides 6. So if 2 divides 6, then it means that 2 divides any multiple of 6. So this would mean then that 2 divides 12, and 2 would divide 18, and 2 would divide 24, and on and on and on. So if you have a number that's a divisor of something, then it's going to divide all the multiples of that quantity as well. That's what this theorem says. Okay? And so they're using this n to be a multiple factor, right? Like timesing it by 2, timesing it by 3, timesing it by 4, so to speak, for what's going on here when you're reading that theorem. Can I go to the next slide? Good. All right, we're going to actually fill in several divisibility rules in this slide that are similar to what you just saw to the last one. They're all grouped together because they have some things in common. So the first one that we'll write down is that if D divides A and D divides B, then D divides A plus B. And if you think about this, again, in that sort of fractional notation, what we're saying is that we can write A plus B dividing by D. Right? That's the fractional notation that's done here. And if you separate them into independent fractions, this is A over D and B over D, with addition between them, of course. So this was a whole number because it was supposed to be divisible. This is a whole number because it was supposed to be divisible. So when we add 2 whole numbers together, we get another whole number. And you can use numbers if you'd like, not letters. I know that some of you don't like my generic letters in here, I can tell already. But let's use some numbers. So if 2 divides 4 and 2 divides 6, then 2 is going to divide 4 plus 6. Does it? Well, yes, because 4 plus 6 is 10. So you can use numbers in there to sort of get that sort of feel to it. All right, another one similar to that says if D divides A, but now D does not divide B, so one of them is divisible, the other one's not, And what do you suppose happens when we compare that over here? Is it going to divide or is it not going to divide? It's not going to divide. And you can do, again, something with evens and odds real quick to make sure that makes sense to you. So 2 divides 4, like we just said a minute ago. 2 does not divide 5, right? So 2 is not going to divide 4 plus 5 either. 4 plus 5 is 9. Does that make sense? So if you divide, if it's divisible on one factor and not divisible on the other one, it's not going to be divisible for the sum. Third one. If D divides A and D divides B, and we're going to actually say that A is greater than B. I'll tell you greater than or equal to B. I'll tell you why on that in a minute. Then D divides the difference as well. The only reason that the A is greater than B is in there is because what happens when you do A minus B? Well, if you're working with whole numbers, which we are, we need A to be bigger, otherwise we get the negative. Right? So A were 4, for instance, and B were 6. 4 minus 6 is -2. The statement's actually still true. It's just not dealing with whole numbers anymore. We're still working with whole numbers until we get to chapter 5. So that's the only reason that condition there is so we can still work with whole numbers. And we can do the same sort of statement that we did on part B. So if D divides A and D does not divide B, and again A is greater than or equal to B, then D does not divide A minus B for the exact same reason. So let's say again that D is an even, D is 2, and A is an even number, say 10, and B is 5. So if we did, well, let's do 3. So if 2 divides 10, that's good. 2 does not divide 3, right? Then 2 is not going to divide 10 minus 3, which is 7. Last one. If D does not divide A, D does divide B, and A is greater than or equal to B. Oops. Then D does not divide A minus B either. So this is virtually the same thing that happened in part D. It's just got the divisibility different. So now if we were doing a number example, we could say 2 does not divide 15, right? But 2 does divide 6. Well, if I take 15 minus 6, it's still not going to work. 15 minus 6 would be 9, so 2 is not going to divide 9. Yes, Audrey? Mm-hmm. Oh, I totally got my symbols in there extra. I got an extra symbol in there. Oh dear, what happened? Just a sec. Yes, I have a symbol in there, Audrey, I'm sorry. That one on C was supposed to say D does divide. I'm sorry. One of you guys are looking at other. Yeah, D does divide on part C, so it's still going to divide, and then on part D and E, one of the two doesn't divide here, right? And so we end up with the result being not divisible. Notice we don't see anything here that talks about D not dividing two quantities and what happens, right? Now think about it with me. If D does not divide, or let's say 2, because 2 is a good example. 2 does not divide 5, right? 2 does not divide 7, right? But what happens when we add 5 and 7? It worked, didn't it? It's 12. So we don't have anything that says, I mean, like, it wouldn't have to work. We could certainly have created something that didn't work, but it could work. So that's why you don't see a rule about it. As being it's always this or it's always that. It's because when you talk about it not dividing a factor, and choose a good example, sometimes it will actually work out that it doesn't, you know, the answer actually ends up being something that doesn't hold true, or holds true, and then sometimes it doesn't. If we use the number 3, for example, 3 does not divide 1, right? Right, it's too small. 3 does not divide 2, right? What happens when you add 1 and 2 together? 3 divides 3, that one works. But what happens if I chose it differently? What if I did 3 does not divide 1? Okay, that's great. 3 does not divide 4. it works. First example, sometimes it doesn't in the second example. So that's why you don't have a rule that says concretely it always does this or it always does that. All right, let's do some that are very straightforward now. You guys know the three that are on this page. But you may not know how to write it in a way that's the same way your book is writing it. So that's what we're going to take a look at on these. Divisibility rules. The first one, divisibility test for 2. How in the world do you look at a number and decide it's going to divide by 2? What do you do? Okay, so what does it take for something to be an even number? What does that mean? Right. So it's really important, right? And we only have to look at one digit, correct? So the number can be extremely long and ugly, but we really only have to look at the last digit. So a number is divisible by 2 if and only if the last digit, or you could say the ones digit, is, you guys can use the word even, you can use the word divisible, or the phrase divisible by 2, or we can specifically say it is a 0, 2, 4, 6, or 8. Any of those would be the same statement. Okay, but it's all about the last digit. How about divisible by 5? It ends in a 5 or 0. Again, it's the last digit issue. So if, I'll write it over here, the last digit is 0 or 5. And then how do we decide if it's divisible by 10? The last digit is 0. Okay, so these are all grouped on the same slide because they all have that same sort of a characteristic that we always look at the last digit to make the decision. So 2, 5, and 10, we look at the last digit to make the decision. All right, so that's not true for all of our numbers. Notice 3 is not on this slide, right? Okay, so we're going to do 4 and 8 next. These you may not have seen before. Has anybody seen a divisibility test or has known of how you decide if a number is divisible by 4? Okay, let me show you how you know if a number is divisible by 4. A whole number is divisible by 4 if and only if the last 2 digits as a whole number are divisible by 4. And I will give you an example so you can actually see how this works. Let me use something besides 32 at the beginning. How about 2536? Okay, so first issue is you've got whatever the expansive number it is you have. You only look at the last 2 digits. Okay? So you're focusing on the last 2 digits. And you take those last 2 digits just exactly as they are. This is the number 36. And you say, is 36 divisible by 4? And on this one, your answer is yes. And if the answer is yes, that the last 2 digits as a complete number in and of themselves are divisible by 4, then the whole value is divisible by 4. Does that make sense? Okay, so let's think through this. Divisible by 2, we looked at the last digit. Divisible by 4, we looked at the last 2 digits. Divisible by 8, we're going to look at the last 3 digits. I don't find this to be a very helpful rule, just so you know, because I don't know my multiplication tables of 8 up to 3-digit numbers, do you? No. But it actually does hold true. So we look at the last, that's the word last, it doesn't look like it. Let's try that again. The last 3 digits as a whole number are divisible by 8. So we could do the same number that I did before. I have no idea if it's going to work, but we can try. It at least stands a chance because it's divisible by 4, so it might be divisible by 8, right? 2536. And especially if you really were working this out by hand, I would prefer to work out by hand if a 3-digit number is divisible by 8 rather than a 16-digit number or something like that. So at least that sort of has an appeal to it. For what we're working with, though, you're welcome to grab your calculator and tell me, does 536 divide by 8? Totally made up this number on the spot. Did you try it, Audrey? 536. We don't add anything together for these numbers. Just like the 3 and the 6, we didn't add the 3 and the 6 to divide if they're divisible by 9. You're divisible by 4. You're getting ahead of us. There's another rule that's like that. Okay. We're not looking at adding anything together. We're just taking the value as its whole quantity. The number is 536. Does 536 divide by 8? Oh, it does. Isn't that interesting? All right, so this number, 2536, must also then be divisible by 8. How did I create that on the spot? That's fantastic. All right, so 536 divisible by 8, then the whole number 2536 divisible by 8. Everybody good with that? Okay, we are just about to the rule that Audrey wanted to use, though, in the wrong spot. But this is it now. So Audrey, do you remember what the one is for 3? You're so close to being right. I got we were good for before. Has anybody else seen the one for 3 before? Okay, so what do you add up? All right, so all the numbers, the unit value, like single digits that are in your number, okay, however long the number is, you add all of those values specifically together, and if you add them all together and the number is divisible by 3, then the original number is divisible by 3. It's a really handy one. So you see how I wrote it on my notes, so I think we're probably. All right, if the sum of the digits is divisible by 3. So if you take the number, we'll just use that 2536 for no apparent reason. Let's take 2536 from 4. And we actually add all those digits together. So we do 2 plus 5 plus 3 plus 6, which is what? 16. Is 16 divisible by 3? No, 16 doesn't divide by 3. So since 16 doesn't divide by 3, 2536 will not either. Okay? These are on the same slide, right? Well, the rule for 9 works exactly the same way. So a number is divisible by 9 if and only if the sum of the digits is divisible by 9. So 2536, we're going to sum them up to 16. Does 16 divide by 9? No. So 2536 will not. All right. The divisibility test for 11 is really weird looking. It's actually really easy to do, but it's very difficult to write down how to do it. So bear with me while I write down how to do it, and then I promise to show you an example of how to actually process it through, okay? You guys do not look interested in me today. Okay, that's all right. All right, so a number is divisible by 11 if and only if the sum of the digits in places of, in fact, I don't even like how I wrote this before. Let me try this a different way. Let's say it this way. In every other place minus the sum of the rest of the digits is divisible by 11. And that's better than what's in my notes. How's that? It's better than what's in your book. Here's what you do. Really really, the divisibility test for 11 is really much more practical if you've got a long number. So you usually see a long number given. So let me give us a 6-digit number, let's say. Got extra comma in there. All right, so here's what you do. You add up every other digit. So 4 plus 3 plus 1 is 8. And then you add up the other ones. 2 plus 0 plus 1 is 3. And you subtract these. 8 minus 3 is 5. If this value is divisible by 11, then the original value was. Is 5 divisible by 11? No. It's smaller than 11 already, so we completely have no shot there. But if we had gotten a value at the end there that was an 11 or 22 or 33 or something like that, then the original number would have been divisible by 11. Now, that's not hard to do, right? But it's really hard to write down what I just did. Okay, so that's what the rule looks like, though. The last one, divisibility test for 6. Any idea about that one? A number is divisible by 6 if it is divisible by 2 and 3. Why would that work? It's 2 times 3 is 6. Now, let's have a little moment here where we have a discussion about this divisibility test for 6. Because you see, the number 8 didn't work like that. I didn't decide if the number was divisible by 8 by checking if it was divisible by 2 and 4, right? But it works for the divisibility test for 6 to check if it's divisible by 2 and 3. So when you compare 2 and 3 to the numbers 2 and 4, how are those comparisons different? Right. And that's the kicker. This test will always work if you can break the number down into 2 numbers that have nothing in common. So if I wanted to do, say, for instance, the divisibility test for 15, can 15 be broken down into 2 unrelated factors? 5 and 3. If you wanted to know if it's divisible by 15, you could decide is it divisible by 5, is it divisible by 3. But you can't always do that with all numbers, right? So let's actually do another one where there's a way to break it down and a way not to break it down. Let's do 18. 18. One way you can break 18 down is 3 and 6. That's no good. Why? Because 6 and 3 have a factor in common. They've each got 3 in them, right? But how else could you break down 18? 9 and 2. And that would work because 9 and 2 have nothing in common, no factors in common. Okay, so this divisibility test for 6 is actually much more broad than just, hey, it works for 6. It works in a lot of cases, but it has to be able to be broken down into factors that are what we call relatively prime. They don't have any factors in common. Okay, nothing in common between them. All right, we're going to use a number, 24015, 24,015. And we're going to decide if it's divisible by each of these values. Okay? So now as you do this in your homework, it's going to look much like this. It just says without using the calculator to decide. So you can simply write down, yes, it works, no, it doesn't. I'll promise you that if I ask you the question on the test, I'm going to ask you to tell me why, right? So if you want to jot yourself down and note why, that's fine. If you don't write it in your homework, that's fine, because it doesn't ask you to. But be aware that you need to at least be thinking about why or it does or doesn't work. So we're going to decide if it's divisible by 2, 3, 4, 5, 6, 8, 9, 10, and 11. So let's do one at a time. Is it divisible by 2? No. And I'm just going to write down the yes or the no, but you have to tell me why. So Taylor, why is it not divisible by 2? It doesn't end in an even number, right? Okay, how about 3? Yes, why? The sum was what? 15. The sum was 15, and 15 divides by 3, so the original value is 25. Is that good? I don't think the sum is 15, though. 12 is what I got. Is it 12? Okay, it still works, it's just the wrong value there. 12, the value 12 divided by 3, so the original value is 25. about 4? No, why not? Yeah, 15 does not divide by 4. What's next? 5. Yes, why? It ends in 5. 6. No. What's wrong with 6? Right. You have to go back and look at the divisibility of 2 and divisibility of 3. 3 was fine. It divided by 3, but it didn't divide by 2, so it won't divide by 6. So this is because it's not divisible by 2. How about 8? No, right? Why? What's the rule for 8? The last three numbers are 0, 1, 5. So it's really just the number 15. But is 15 divisible by 8? No. So it's not going to work. This number is not divisible by 8. So the whole number is not divisible by 8. How about 9? No, why not, Katrina? Right, the sum was 12, and 12 is not divisible by 9. How about 10? No, why not? Right, doesn't end in 0. And to do 11, so let's do 11. We actually have to write it out, right? So I'll do it from up here. So the green numbers add up to 7. The numbers that I didn't circle add up to 5. And the difference is 2. So, no. And it's because, I haven't written because on any of the others, so, but it's because the sums are 7 minus 5, which equals 2. Let's say it that way. 7 minus 5, which is 2. And 2 is not divisible by 11. Okay, what do you think? Is that doable? Okay. We're going to do a true-false, so a few true-false questions. Classify each of the following as true or false. If a number is divisible by 6, then it's divisible by 2 and 3. That is true. That is exactly one of the divisibility rules. So that is true. If a number is divisible by 2 and 3, then it is divisible by 6. Also true. And the reason, although that may feel like this is saying the same thing, is it isn't. It's actually saying it in exactly reverse, right? One of it's saying it's divisible by these two things, it's divisible by 6. The other one's saying it's divisible by 6, it's divisible by those two things. Okay? The reason that actually worked is because if we go back up to our divisibility rule, over here there's a phrase. We didn't focus too much on it, but the phrase was if and only if. If and only if means that it goes both directions. You can start on the left and the following result can be true on the right, or you can start on the right and the result from the left is true. You can go in either direction. And if you'll take a look back, our divisibility rules all said that. Alright, so we could actually do the same sort of an argument with true false on any of these rules. I could do, for instance, up here, if the sum of the digits is divisible by 3, then the value is divisible by 3. Yes. If the value is divisible by 3, then the sum of the digits is divisible by 3. Yes, it's just going the other direction. Alright, C. We've talked a little bit about this now. C says, if the number is divisible by 2 and 4, then it's divisible by 8. That is false. And often when I ask you something that's false on a test, what do I have you do for me, Brianna? Do you remember?
Explain why.
Counterexample. So let's think with you. Think if you can. I'd like for you to find a number that's divisible by 2 and 4, but it's not divisible by 8. 16 is divisible by 8. 12, I think 12 would work, right? Is 12 divisible by 2? Yes. Is it divisible by 4? Yes. Is it divisible by 8? No, it doesn't work. So this is a counterexample. D says a number is divisible by 8 if and only if it is divisible by 2 and 4. That is also false. So on this one, that if and only if language is coming into play, which means we have to be able to start on the left and go forward. We have to be able to start on the right and go backward. Well, if we start on the left and go forward, this actually works. If a number is divisible by 8, it is divisible by 2 and 4. That's actually true. Think about your multiplication tables of 8s, right? So you have 8, 16, 24, 32, all those numbers. All those numbers in that list of multiples of 8 are divisible by 2, and they're divisible by 4. It's the other direction, which is exactly part C, that causes problems. If a number is divisible by 2 and 4, it is not necessarily divisible by 8. All right? So this is false because of the second, I'll call it direction, namely divisibility by 2 and 4 is not always divisible by 8. Could it be? Could we create some? Sure. But there are some that can be created that don't work too. All right, let's take a look at another one. We're supposed to answer each of the following without actually performing the division. So we're not really supposed to be able to pick up a calculator to check our work. We'll make a decision without that. All right, so here is the first one. Obviously, it's talking about divisibility by 17, and there were no rules about 17, so we have to be using other thinking as we're looking at this. We have the number 34,015, and we want to know if that's divisible by 17. What do you think? It doesn't work. You're right, Avery. Do you know why? What about the 34? Yes. So if you break this apart into kind of two pieces, which is actually one of our estimation methods back in 3.5, do you remember that? Where we sort of broke things apart and we said, well, let's see if there's a way to do this where we can actually look at it in pieces. 34 would actually work, right? What is 34 divided by 17? It's 2. It's exactly twice as big. The problem is that while that piece works, the 15 doesn't. 15 is not divisible by 17. So this one, it doesn't work. So because, and I'm going to use the actual, I've been avoiding it, but I think I need to use it so you can see me use it. Because 17 divides 34, right? That's how you read that. 17 divides 34, but 17 does not divide 15. That's what we said in notation. How about part B? That one actually works. Why? Yeah, 34 is divisible by 17. We already did that one. 51 is actually divisible by 17 as well. What would you get if you divided 51 by 17? It's 3. Yeah, so this one works for exactly the same reason that the last one didn't. Because 17 divides 34 and 17 divides 51. It actually both works. How about C? What do you think? Nope, it doesn't work. Why not? No, because what? Right. 19 works, right? 19 is divisible. I wrote it wrong. Try it again. 19 is divisible by 19, but just like Avery said, the 31 is not divisible by the 19. You write it correctly. 19 does not divide 31. D is interesting, and D does not involve you multiplying anything out. Please do not multiply D out, or E for that matter. Is 2 times 3 times 5 times 7 divisible by 5? Absolutely. Why? Because there's a 5 in the multiples list, right? If you were to multiply this number out, it would have to end in a 5 or a 0. Because there's a multiple 5 in there. There's a factor of 5 in there. So yes, this works. Another way you can think about it is somewhere along the way in probably middle school, you actually worked at sort of factoring things out into their simplest form and writing them on top of each other, like when you were looking at reducing fractions. If you actually had this thing written out as 2 times 3 times 5 times 7 over 5, what would you do? You'd cancel out the 5s and you'd have no fraction left, right? You'd have a whole number left, right? It has that same feel to it, it's the exact same reason. So is this one divisible by 5? The answer is yes, because what it means to be divisible is that 5 is a factor of 2 times 3 times 5 times 7. What about the next one? Definitely not going to work. Why not? What happens when I add one? Well, what was it? A 1 or a 6, right? This is exactly off by 1. Whatever the number was originally, it had to have ended in a 0 or a 5 because it had a factor 5. You add 1 to it, now it has to add in a 1 or a 6, so it's not going to work. So this one is no. It will end in 1 or 6, exactly because the last one had to have ended in a 5 or a 0. Any questions on that one? All right, example 4. If 24 divides a number m, what other numbers would have to divide that value? 6. Why? Because 6 is a factor of 24. So what else? 12. I don't think 18 would work. 2 would, 3 would. 4 would. 8 would. One other number. It's not a very exciting number. 1. Yeah. Okay, so when you're thinking about what numbers divide things, one way to do that is to actually simplify this into the pairs of numbers that multiply to give you 24. So what we could do is we could write this as, okay, this is 1 times 24, or it's 2 times 12, it's 3 times 8, or it's 4 times 6. That's the only way we multiply numbers together to get 24. 2 numbers together to get 24. So all of those numbers would actually also have to divide whatever this number m is, because they're factors of the number 24. All right, what about filling in the blank? We're going to fill in that blank with a number. We want to know what numbers could go in the blank. So the following number is divisible by 2, part A, 2, part B, 3, and part C, 6. So let's start with 2. I just want to know what numbers could go in the blank, so so that this whole number, 543,220 blank, is divisible by 2. What number could go in the blank? Right. Any of those numbers could go in the blank and the number could be divisible by 2. How about about 3? Taylor, I'm going to pick on you a little bit because you told me the 2 and you're right. What were you thinking to get to? Okay, so you added the numbers together to start with because that's the divisibility rule by 3. When you add those numbers together, what do you get? 16. All right, so the sum right now is 16, right? So what would I need to add to 16 to get a number divisible by 3? Well, 1 doesn't work because that's 17. 17 doesn't work. But the number 2 would actually give me 18. Right? So if I had the number 2 in there, I'd have a sum of 18 and that would work. Well, the only way that I could get, if I keep going down this list, if I put 3 in there, that'd be a sum of 19, 4 would be a sum of 20, 5 would be a sum of 21. So 5 would work. 6 would be 22, 7 would be 23, 8 would be 24, so 8 would work. 9 would be 25, so it doesn't work in round digits. Obviously 0 doesn't work either, so it was 16 to start with. So we're just testing all the numbers to see which one adds to 16 and gives me a number divisible by 3. So how do I decide on number 6? Right, it has to be in both lists, right? So we look at what the lists have in common. They both have a 2 in them, so if it were a 2, it would be even, yay. If it were a 2, it would add to a sum of 18, yay, all divisible by 3. 8 worked as well because it's in both lists. So both the numbers 2 and 8 would make the whole value, divisible by 3, and 6, or 3 and 2, which gives me divisible by 6. Alright. Justify your answer always means it's like when I fill the test, explain, right? So we're going to have to explain why on this particular one. Answer the following and justify your answer. If a number is divisible by 5, can it be divisible by 10? It can be, sure. So yes, it can be. Why?
Sometimes 5 ends in.
Yes. Okay, so yes, because some, that does not, too many of somebody in, some multiples of 5 end in 0, making them a multiple of 10, or making them divisible by 10 if you prefer. All right, that works. Absolutely true. If a number is not divisible by 10, can it be divisible by 5? Yes, it can. Can you give me an example? Okay, so can you give me one? 35. 35 is not divisible by 10, but 35 is divisible by 5. Now let me change the question slightly. So this is sort of my making up on the spot part C. What if part C said, if a number is not divisible by 5, can it be divisible by 10? No. Because what would have to happen for it to be not divisible by 5? It can't end in a 5 or a 0. So if it can't end in a 5 or, in particular, a 0, then it certainly can't be divisible by 10. So the order of the way that the question is phrased really makes a big difference on these. All right, example 7. A number in which each digit except 0 appears exactly 3 times is divisible by 3. For example, 777, 555, 222. And 414, 143, 313 are both divisible by 3. So the first number you see, they're actually grouped together, right? 3 7s, 3 5s, 3 2s. The second one, they're not, but if you look carefully, there are 3 4s, there are 3 1s, and there are 3 3s. Can you see that? So any number that has that pattern always will be divisible by 3. The question says then, explain why this statement is true. Why would that always work? There are 3 of them, right? So if you add something together 3 times, you get something divisible by 3, don't you? And that's what that sum rule tells us, or that's what the divisibility rule, being a sum rule, tells us from divisibility rule by 3. So, because there are 3 of the number, so let's say the number's A, then A plus A plus A is 3A. And 3A is divisible by 3. Nothing special about the particular number, right? You're just adding to itself 3 times, so you're going to get something divisible by 3 when you're done. Must this statement be true in order for a number to be divisible by 3? That is, must you have a number where it triples the number within it in order to have a number divisible by 3? No. Can you give an example, Avery?
3,312.
That would work. Okay. This number, is it divisible by 3? Yes, it is, right? Because 3 plus 3 plus 1 plus 2 is 9. Yes, it is 9. 3 plus 3 plus 1 plus 2 is 9. So this number is divisible by 3. But this does not have 3 3s or 3 1s or 3 2s in it, right? So this is just a very special kind of an example where we have something divisible by 3. It's not a requirement to make something divisible by 3. The only rule requirement, so to speak, to make something divisible by 3 is that the sum of the numbers has to add up to something divisible by 3. All right. Just a sec.